Databricks and all the other big tech companies are asking this question over the past 6 months. This is Leetcode House Rubber, the second version. You can find the original version on the link below. We are given an array that indicates the value of the house. In this case, it becomes the circle, and the two adjacent houses cannot be rubbed at the same time. And that's the only difference than the original version of this question. For example, for the array 2, 3, 2, the only maximum profit we can gain is rubbing the second house here, because the first and the third, they're attached to each other. For the array 1, 2, 3, 1, the maximum profit we can gain is rubbing the first and the third. Next, I'm going to talk about a backtracking dynamic programming approach, which is taken O(n) time. Because the houses are linked in circle, we can actually find the maximum between starting from the first element to the second last element, or we need to find the subarray starting from the second element to the last element, so that we can find the maximum profit between those two subarrays. Now let's dive into how to solve this problem. Suppose we have a nums like this. We can declare the DP array just like a copy of the nums. Suppose we have an index I that's starting from the second element. Because we cannot rub the adjacent house, so we either can rub I and I-2 or I-1 individually. And there is something we can improve. Instead of rubbing I and I+2, we can find the maximum between the subarray 0 to I-2. And here is how the algorithm works. Suppose we have an I starting from second index. 1 plus 7 is greater than 4, so this will become 8. And we move the index I to the next. We have 9 plus the maximum of 7 and 4, in this times 7. So 9 plus 7 is greater than 8, so we have 16. And we move I to the next. Number 3 plus the maximum of this subarray is 3 plus 8 is 11. It's less than 16, so this becomes 16. And we move I to the next. 8 plus the maximum of the subarray, which is 16. So 8 plus 16 is 24, is greater than 16, so this becomes 24. Now we cannot move to the next, which is the last, because the last is attached to the first element. So we stop here and return the maximum, which is 24. And here's the Python code. I have an if statement here, just in case the length of the subarray is less than 1. And we need to compare the maximum between the subarray that's starting from the second element to the last, and the subarray starting from the first to the second last. If you like this channel, please click like and subscribe. Thank you.